Here's an algebra review in several parts. A little coaching as to how to watch this video. First of all, make sure you have a paper and pencil. Whenever I ask a question, pause the video and try to answer the question. And if you can't answer the question, then you can listen and watch my answer to the question, and then proceed to the next step. If you're able to easily answer the question, then you can just proceed, fast forward to the next part of the review, skipping those areas that you don't need to review. Okay, let's start with the first item. Here's a set of 9 algebraic properties. I want you to pause the video and in words and equations and examples, see if you can explain and demonstrate your understanding of each of those properties. Once you've done, come back to the video and we can go over it. Okay, when you do assignment 1, you'll see that you need to know what these properties are. Here are some examples. This is what you should have written down. If you're able to do this, you can fast forward to the next part of the video. If not, let's just briefly go over each of the properties. The commutative property means that you can change the position of things. You can commute or move around things in any order if you're just doing simple multiplication or simple addition. So 3, 4, 5 will give you the same result as 5, 3, 4. ABC will give you the same result as BCA. 3 times 4 times 5 will give you the same result as 5 times 3 times 4, and the same if you use symbols. The associative property means you can do procedures if it's just simply addition or multiplication in any order. So 3 plus 4, then add 5, you'll get the same thing as if you add 3 to 4 plus 5 added first. And the same way for multiplication. That's the associative property. Identity property we use all the time, solving equations. It's intuitive in a way. If you add 0 to any number, you get the identical thing. 5 plus 0 is 5, a plus 0 is a, x plus 0 is x. The additive inverse, if you want to eliminate something from one side of the equation, you add the additive inverse. So if you have a 5 and you add a negative 5, you'll get a 0. And in a general sense, a plus or minus a gives you a 0. To not change things in multiplication, you multiply by a 1. So you can always multiply by a 1. So 4 times 1 is 4, a times 1 is a. And if you want to turn something into a 1 and thus eliminate it from one side of the equation, you multiply by the multiplicative inverse. So 3 times 1/3 gives you a 1, or any number a times its multiplicative inverse 1 over a will give you 1. The distributive property and factoring, we do a lot of that in equations. If you have a situation where you have a times b plus c, that is identical to a plus b plus a plus c. You distribute the a over the two addends. Similarly, going in the reverse direction, if you have an expression ab plus ac, you can factor out the a and rewrite it and put it in this form. So those are the properties of multiplication. So the properties of algebra. Let's close this down and put it away and go to the next. So, oops. working. Let me stop the video. So whether it's numbers or symbols, you have to be able to do these simple operations. So pause the video and do 2/3 times 1/4, 2/3 plus 1/4, and 2/3 divided by 1/4. Okay, you're back. Although this may seem simple, you'll see that you're prone to make mistakes when you do this. So let's take a look at my answers to these and some others. So one of the things is pay attention to what you're doing. Think about what you're doing. So 2/3 of 1/4 has to be less than 1/4, right? Because you're only taking 2/3 of the quarter. So let's see what we're getting. Well, when you do the multiplication, you can add the numerator. You multiply the numerators and you multiply the denominators. So 2 times 1 is 2, 3 times 4 is 12, 2 twelfths is 1/6. 1/6 is less than 1/4. It makes sense. 2/3 of 1/4 would be 1/6. So if you have an equation with symbols and you have AB times CD, you simply multiply the A and the C and the B times the D. When you're adding, you have to have a common denominator. You can't add 2/3 and 1/4 directly. And think about what you're doing. In this case, the answer has to be bigger than 2/3. 2/3, of course, is bigger than 1/4, and so we're adding 1/4 to 2/3. If we added 1/3 to 2/3, it would be 1. So we can almost guess what the answer is going to be, a little less than 1. Let's see. So you have to have a common denominator. So the common denominator, the closest common denominator we have here is 12. So how do we get a common denominator by 12? We multiply by 4/4. Why can we multiply by 4/4? Because 4/4 is 1. We can always multiply 2/3 times 1 and get 2/3. Remember, multiplicative identity. So 2/3 times 4/4 gives us 8/3. And to get a denominator of 12 here, we multiply by 3/3, which is really 1, which is the multiplicative identity. It doesn't change anything. So 3 times 1 gives us 3, 3 times 4 gives us 12, and now we can add them. We have 8/12, and we're going to add it to 3/12, and we get 11/12. Good. That's what I was expecting, something a little bit less than 1. So that's a good indication that we did it right. If you're doing this in general terms, you see what you do. The common denominator for A plus B plus A over B plus C over D has to be BD. So if we take the AB and we multiply it by D over D, that's 1, we get AD over BD. Then we take the CD and multiply it by B over B, which is 1. This is symbolically what we did here. And we get CD plus BD. So we have a common denominator, BD. We just add the two top parts. So the answer is AD plus CD over BD. Did you get that right? I hope so. That's if you did it. Okay. So 2/3 divided by 1/4. These are the trickiest and also something prone to mistakes in algebra. So what I do is I always remember the rule, invert and multiply. But think about the logic here. If you had 2/3 and you divide it by 4, that means you're dividing 2/3 into 4 parts. It's going to be very small. So logically, if you're dividing by something small, it gets bigger. Anyway, if that doesn't make sense, just remember the rule, invert and multiply. So 2/3, you invert the 1/4 to 4/1, and you multiply, and we know how to do that. We multiply the numerators, we get 8. We multiply the denominators, we get 3. So we get 8/3. So dividing by a fourth is the same as multiplying by 4. And if we did that symbolically, we would have a over b divided by c over d. We would invert the c over d to d over c and multiply to get ad over bc. That would be the generalized answer. So you're back. Let's put the question away and pull down the answer. So the first thing I do is I bring the 3x over to the side where the x is, because we have to collect our x's, so to speak. So how do I do that? I do the additive inverse. So I take 3x and I subtract 3x. I have to do that to both sides of the equation. That's the basic rule, right? Whatever you do to the left side, you do to the right side. So that gives us 0. Now over here we have 7x plus 2 minus 3x. We can use the associative, the commutative law, right? We can move this over here and we get 7x minus 3x plus 2. Then I use the distributive law. I have x and I pull out the x. I factor out the x and I get 7 minus 3x plus 2. 7 minus 3 is 4. 4 times x plus 2. I need to get the 2 to the other side of the equation, so I use the additive identity. I have 2. I add a negative 2, so I have to add a negative 2 to both sides of the equation. I got 4x now plus 0 equals negative 2. 4x plus 0 is 4x. That's the additive identity. And now I need to use the multiplicative identity to get rid of the 4. I have to multiply 4 by 1/4 or divide by 4. So I take the 4x, I divide by 4. I have to take the negatives, this side, negative 2, and divide by 4. And I get 1x. 1x, of course, is x. And I get negative 1/2. And so that's my answer. So this you can do, but it's useful to, at this point as we review, to pay close attention to our use of the properties. You see there's actually quite a few steps to solve this equation, which in some ways you could almost do in your head. Okay, let's move on to the next part. Put this away and pull down the next question. So here's another algebra problem. Here's an equation that we'll see next week. I'll tell you what it is. Vf is the final velocity, so an object is moving. It has an initial velocity, v initial, a final velocity, v final, and if it's a changing velocity, then it has an acceleration. And so you find we have an equation for finding the final velocity. You simply start with the initial velocity, and you add the acceleration times the time. So here's an equation. It'll be on your equation sheet. You'll use it to solve problems. But what we might know the final initial velocity and the acceleration, and we want to find the time. So do your algebra, pay attention to the steps, and solve this equation, this symbolic equation for time. Pause the video and do that. Okay, you're back. You've done it, I hope. Let's put the question away. And take a look at the answer. So we want to get the t by itself. So I add a negative v initial to each side of the equation. This becomes 0. And so I have V final minus V initial equals AT. Right? Don't look at the A's. I actually didn't write it all out. So I didn't show the 0 here. So AT equals V final minus V initial. Now what do? I want to get rid of the A, so I divide both sides. Remember, both sides, the entire of both sides, by A. A over A is 1. That'll leave me with T. Whoops. And then I just change the order. I move the T to the left side, and I move this expression to the right side. And there's my solution. The time is equal to the final velocity minus the initial velocity divided by the acceleration. Okay, let's put this away and do the final problem. Things are getting more interesting. So in this case, we have two equations. The one I just showed you, V final plus V initial, V final equals V initial plus AT. And I have a second equation. Delta x, that's the distance that an object travels. You don't need to worry if you understand all this now. We'll talk about it next week. You can just look at these as symbolic equations. So V final plus V initial, if you take the final velocity plus the initial velocity and divide by 2, this whole thing is the average velocity, right? The final plus the initial divided by 2 is the average. And so the average velocity times the time will give you the distance you travel. That should make sense. Okay, so we want an equation of motion, an equation, so-called kinematics equation, that doesn't have time in it. So we have two equations, and we're going to eliminate the time. So this is a situation of two equations, and we eliminate one of the variables. So you do that by substitution. So see how good your algebra is. See if you can take these two equations and come up with a third equation that doesn't have time in it. And then rearrange that and simplify it so that it looks good. Okay, pause the video and try to do that. All right, you're back. Let's take a look at the result. So, remembering what we did earlier, we had this equation and we solved for time. So t is equal to this. I can take this quantity, which is equal to t, and I can substitute it here where I have t. In other words, t equals this, so I take this t away and I put in what's equal to the t. So you see I have the delta x, I have this term, and then here's my new form of t, and I've eliminated t from the equation. So here's my equation with no t in it, but it's not very simplified form. So what I see is I have the difference of two squares. You may recognize this. V final plus V initial times V final minus V initial. So this is like two fractions multiplied together. We multiply the numerators, we multiply the denominators. When we multiply this together, we end up with this. When we multiply these two together, we end up with this. And then I rearrange it in the form that we usually display it in. And see if you can follow the algebra from here to there. What I do is I multiply both sides by 2a. So I have 2ax equals V final squared minus V initial squared. And then I move the V initial over here, and then I switch the two sides of the equation around, and I end up with my final result. You'll see that this is an equation on your equation sheet that we'll use next week to solve problems. Now, it's useful what I want to do, the final step, is to take a look at the details of this multiplication. It's kind of an interesting application of the distributive law. So pause the video and see if you can do out the v final plus v initial times v final minus v initial and get this result. See if you can do that. Pause the video and try. Okay, you're back. Let's take a look at it. Let's close this down and pull up the answer. So here we go. We have the two terms I was talking about, the v final plus the v initial, the v final minus the v initial. Now watch how the distributive law works here. What I'm going to do is I'm going to take this term, think of it as a term, this bracketed parentheses, and I'm going to distribute it over these two terms. So I'm going to take this and I'm going to multiply it by the v final, and then I'm going to take this and I'm going to multiply it by the v initial. So you see that's what I did here. Here's the v final multiplied by the bracketed term. Here's this negative sign. Here's the v initial multiplied by the bracketed term. So that's the first distribution. Now let's look at, now we have to do the second distribution. So now I'm going to do this and this. So v final times that, v final squared, v final times that is v final times v initial. It's a plus sign. Now this is a negative v initial. So when I distribute this, well, let's leave the negative sign there. Let's distribute this in, and I get v initial minus v final. And this would be v final squared, so I have the negative sign gets distributed over both terms. So this becomes negative v initial v final. This becomes negative v initial times a positive v initial is a negative v initial squared. Now this is v final minus v initial. V initial, that's the commutative law, right? We can change that order around. And v final v initial minus v final v initial is 0. So this term goes to 0. And we're left with what I said. Okay, so if you can do this kind of algebra, you're in good shape. If you can't, you should practice. Thank you.